Hi, good afternoon, everybody. Welcome to another episode of Math with the Thinker's Cap. Okay, my name is Mr. Tam. Okay, in this lesson, we're going to talk about how to answer questions in vectors involving grid squares, right? Okay, where we are asked to express vectors, right, in terms of two vectors that are given to us. All right, okay, so in this case, with the grid square, of course, we're going to make use of the grid square to do counting and to see how many of each type of vectors and the scalar multiple of the vectors required to form the new vector. Okay, so let's take a look at this question here. Okay, we have got four vectors here: lm, st, pr, and x, y, and we need to express them in terms of vector a and vector b, right, which is given, okay, on the left side of the grid. All right, okay, so in this case, okay, let's take a look at lm first, right? So lm starts from l and ends with m, right? So I'm going to use vector b, right, to draw a parallel line. So in this case, if you are using a set squares, right, you can draw the parallel line, okay, or vector b, and let the starting point be L, right? So in this case, we can do counting of squares, since I cannot use a set squares, okay, in this particular lesson here, right? So 2 squares by 3 squares, okay, I'm going to use red here, right? That will give me 1 times the vector b, right? And my ending point is m. So if I'm going to continue with b, it may overshot and I will not be able to reach m, okay, if I add on to my vectors, vector a here, right? So I'm going to try adding from here, okay, vector a, and see whether I can reach m. So over here I already have, okay, b, okay, going to add 1a here and 2a here, and my ending point is m, right? So in this case, this will be 2a, and therefore my lm, okay, is actually equals to b plus 2a, right? And that is my first vector. All right, so let's look at st now, right? And for the purpose of illustration, I'm going to use a different color, right, to show you. Okay, let's change it to purple in this case, right? So st, I'm going to start with s. All right, so I'm going to draw vector b first. Okay, move it down. Okay, 2 squares by 3 squares. All right, and I have to continue moving it, right, because I have not reached the part where I can add my a to reach t, right? It's too early, right? Okay, so I'm going to add another b and see how it goes, right? Another b, so I've got 2b here, right? So from here, probably I can try adding my vector a here. So over here I've got 2b. Okay, I'm going to add vector a here and another vector here, right? So I've got 2a here, and my ending point is t, right? Therefore my st is equals to 2b plus 2a. All right, okay, let's look at vector pr in this case, right? Okay, so let's change to another color. In this case, I'm going to use blue. All right, you realize that the ending point of r does not end, right, exactly on the vertices of a square. It ends halfway, right? So in this case, I will expect one of the vectors or both, right, to be a fraction scalar, to have a fractional scalar. Okay, in this case, likely there could be a half involved here. All right, okay, so in this case, okay, let's start drawing from my vector. Starting point is p, right? Okay, we're going to start from by adding vector b here. So I've got 3 squares by 2 squares, so I've got 1 here, right? And halfway through, right? So probably I will continue halfway through, right? And probably I will stop here, because if I go to continue, I would not be able to add another vector a with the ending point ending at r, right? So I will stop halfway here, right? So this will actually be 1.5 b. So it's 3 over 2b, right? In this case. So from this ending point, I'm going to add my vector a down, right? Okay, and this is actually parallel to my vector a, but in the opposite direction. So in this case, it's minus a, right? And therefore, my PR is actually equals to 3 over 2b minus a. All right, okay, and we have our last vector x, y, right? So I'm going to use another color. Okay, so in this case, I'm going to use green. All right, so I'm going to move the vector up, all right, using vector b instead of a, because b would enable me to move the vector up, okay, using so-called a cross, right? So that I can find out, it's easier visually for you to see how many a's you need to add later, right? Because a is going to be very close, right? Okay, so over here I'm going to add using vector b, but it is in the opposite direction, right? So I'm going to move up. Okay, 3 squares by 2 squares, move up here. Okay, and I have to continue moving up as well, right? Okay, 3 squares by 2 squares. Okay, another b, right? So in this case, probably I can start adding my vector a already, right? Okay, in this case, because y doesn't end exactly on the vertices of a square, is halfway. In other words, I will expect, okay, one of the vectors to have a scalar multiple involving a fraction, right? In this case, probably involving multiples of half, right? Okay, so in this case, I will have minus 2b here because I'm moving in the opposite direction, and I'm going to start adding my vector a. Okay, 1a, 2a, and 2.5a. Okay, so I have an ending point at y. So this is going to be 5 over 2a, and therefore my vector x, y is equals to minus 2b plus 5 over 2a. Okay, and there you have it. Okay, my 4 vectors resolve and express in terms of vector a and vector b. And this is one way, okay, where you can make use of the grid square, okay, to resolve the vectors. So if you like this lesson and you'd like to find out more about our lessons, okay, click on the link below and find out more about our classes, and I hope to see you on the other side. Thank you.